It's been years in the making, but maybe the future of the Jetsons is real close. Well, we're here with Dexter Vizinau of CyberTran. CyberTran, tell us what you guys are doing.
Well, CyberTran is a company that will manufacture ultralight rail transit. It's a transit system of the future, and it's disruptive technology in that it's a tenth to a quarter the cost of traditional transit systems with a zero carbon footprint.
What's the transportation internet?
Well, we are a cross-platform technology, and by platforms I mean there's low, medium, and high speed. So low would be urban circulators around town, and then medium speed would be considered commuter rail system where you connect cities, and then a high-speed network where you connect regions. And so in one vehicle you can go across all these platforms in one vehicle because they're all connected. Similar to our highway and road system. But think about it, you can get in your car and you can drive from here to New York and you never drive on dirt because all our roads, our bridges, and all our highways are all connected. In one vehicle you can go all the way. It's the same analogy here. So if you look at my hand, let's say my hand is a network and it's a city, and you've got at each joint there's a stop. You can go from any one point to any one point direct. When you build out one city and you build out another and you connect the two, now you have a commuter rail system and you can go in the vehicle from any one point to one point. You take a region and then you build out another region and you connect those two and it'll go up to 150 miles an hour. So it's direct to destination anywhere into our network. It's a network. So therefore we call it the transportation internet.
It seems like you can, with that model, you can start off very small, even at a private development or something that's relatively small, but you can expand out from that, right?
It's organic.
Yeah, exactly.
It grows, and the thing about it is it doesn't slow the system down when you put stops on it. And you can take an area where there is nothing and create a destination and then, take transit to it.
And the reason it doesn't slow things down with the stop, why don't you elaborate on that for a moment?
It's direct to destination because our stations are off the line. It's just like when you're on a two-lane highway and you pull off to get gas, you're not holding up traffic on the highway. When you pull off to get gas, you can go in the direction that you were heading or you can go back from the direction that you came. So our stations are off the line. There's not a platform that's on the line that holds up traffic on the main line.
It seems like those platforms in themselves could be opportunities for cities or for private developers to create communities of interest.
I think we put the T in transit-oriented development.
So you're giving all the advantages of mobility that people want, that on-demand, where they want it. Why don't you talk a little bit about the actual infrastructure itself, these rails?
By lowering the weight of the vehicle, you lower the infrastructure, the amount of infrastructure that's needed to carry those vehicles. And so by lowering the weight of the vehicle and lowering the amount of infrastructure, you wind up lowering cost. And you can get it down to a certain point to where you can start prefabbing your civil structures off-site and bringing them out and putting them together.
So this is an all-electric vehicle.
Yes. So
tell us how you're getting that electricity.
Well, we have the real estate above the guideway, and so we can put canopies along the guideway over the civil structure, which kind of acts like it's not a tunnel, but it's a canopy, and the vehicle goes under it, and through a third rail, there's connectivity from the photovoltaic panels array down into the third rail. And so that will feed the system. We generate approximately a megawatt a mile. It's about 8 times more energy than we consume. So really what we have is a power grid. It's a power grid that has a transit system in it. So we are feeding communities energy wherever our transit systems go. We're generating electricity, and we are giving that energy providing that energy to communities, surrounding communities.
Well, I guess that kind of makes sense given the roots of this. We're actually in the Department of Energy, right?
Yes, actually, the system was designed and created at a Department of Energy lab, the Idaho National Lab, whose campus is the size of about Rhode Island, and they wanted a transit system, and it was sticker shock. So they decided to design their own. They built 2 prototypes, fully tested, and when it was ready to deploy, the program funding got cut. So our company was founded at that point. We got the rights to the technology, and we are now working to finish what they started. And we also have some DOE labs that are interested in working with us to finish what they started.
So what are the next steps, or what's the path between here and commercialization?
Our demonstration track, which we are going to do at UC Berkeley's Research and Development Campus, the Richmond Global Bay Campus in Richmond, and we have 20 acres there that we plan to build our showroom for the world. Once we do that, it's a 2-year project. It's 1 year to build and 1 year to test and certify. Then we're ready to go public. The city of Richmond is making plans to be the first to deploy a system, and so they will be going through environmental impact studies and those type of things, getting it in the general plan and the type of things that municipalities need to do in order to have a system.
And from a scale perspective, you're really kind of the center of an ecosystem that includes some big partners, right?
Yes, it is. We have a whole team that is working with us. It's not just our company. We have universities. We have, like I say, national labs. We have some private partners. We've got engineering companies. We got civil structure companies, and we've got architects and designers and companies to help us ramp up our manufacturing. As I said, we plan to manufacture transit systems in America, made in America, built in America.
Excellent. Well, I appreciate your time here, and good luck in the next phases.
All right. Thank you so much.
Thanks,
Really appreciate it. All right.